Okay, now we will go through the exemplar questions in the chemical bonding chapter. See, here you will have to remember the atomic number and valence electrons, some of the important atoms from the periodic table. You will have to also remember the electronegativity of some important element. See this carbon, fluorine, hydrogen, other things. Okay. First question: isostructural species are those having same shape and hybridization. Among the given species, identify the isostructural pairs. Okay, here you see boron valence electron 3, nitrogen 5. But we have this boron, here is a minus sign, so you have to add one more electron. There is a plus sign, you have to subtract one electron. So the four electrons on both the atoms. But this fluorine and hydrogen also forms a single bond. So the four valence electrons, single bond. So four orbital, one s plus 3p, sp3 hybridization. Okay, this book 50. So if you have gone through this, see here, they given what is the structure of this NH4 plus. Okay, so the option 2 is the correct answer. Polarity in a molecule and hence the dipole moment depends primarily on the electronegativity of the constituent atoms, the shape of the molecule. Which of the following has a net highest dipole moment? You see from the book you can see CO2 is a 0. Hmm. See, dipole moment is the vector addition. Okay. See here CO2, the oxygen, more having more electronegativity than carbon. So the arrow points this side, this arrow points this side, minus x and plus x. So the it will cancel out. Then vector addition will become 0. So there is a zero dipole moment. But water, see hydrogen, oxygen having more electronegative. The here the y component, vector y component above and below will cancel out, but there is a x component. So 1.85 d is the dipole moment of the water that is given in the book. Okay, in the book 13. See here, dipole moment of water H2O 1.85. Okay, for the other elements also there is a dipole moment, but that is less than the water. Okay, so option 3 is the correct answer. The type of hybrid orbitals of nitrogen in NO2 plus NO3 minus respectively are this nitrogen valence electron is 5, but there is a plus sign. So here 4 and here there is a minus sign, here 6 and there is a plus sign here also 4. But oxygen forms a double bond with nitrogen, hydrogen forms a single bond. So 4 valence electron double bond. So this is 2, that is sp, 2 orbitals sp. Here 3 orbitals sp2. Here 4 orbitals sp3 because hydrogen forms a single bond. So this is the correct answer. Hydrogen bonds are formed in many components. Example H2O, HF, NH3. The boiling point of such a component depends in large extent on the strength of the hydrogen bond and the number of hydrogen bonds also matters. The correct decreasing order of the boil C here. Fluorine is more electronegative than oxygen than nitrogen. The oxygen is greater than the nitrogen. So based on this, we have to put HF at the first, then HO, then Mn. But here we have two H hydrogen bonds. So HF only one. So here they mention number of hydrogen bonds also matter. So the water comes first. So water, HF, then NH3. In this PO4 3 and formal charge, they are asking on the oxygen atom, and there is a single bond. So here, book page 5. Page 5. Here you see. See, we have this phosphorus, oxygen, single bond. So number of electrons, valence electron in the oxygen free atoms is 6. So number of lone pairs is 6. Minus half into number of bond pairs. This is 2 electron in the bond pair. So we have a net charge of -1. Here important thing is that is oxygen and there is a single bond. I think those two only matters. In NO3 ion, the number of bond pairs and lone pairs of the electron in the nitrogen are NO3. See, this is the Lewis structure of NO3. They are asking bond pairs. So here this is a double bond and this is a single bond, this is a single bond. Okay, so the bond pair 4, there is no lone pair, that is 0. Okay, 4 bond pairs and no lone pairs. Which of the following species have a tetrahedral geometry? So in the from the book you can see these things. So the first option is correct. Number of 5 bonds and sigma bonds in the following structure. The important here you have to note the double bond has one pi bond and one sigma bond, and all the single bond have only sigma bonds only. So here they are asking pi bonds to sigma bonds. So first you have to see the pi bonds. So each double bond have one pi bond. 1, 2, 3, 4, 5. So there are 5 pi bonds. There are only two options are there. Now second you have to find the sigma bond. Sigma bond, see each pi bond has one sigma bond, each double bond has also one sigma bond. So 6 plus 6, 12. So this is in both sides. 6 plus 6, 12. 13, 14, 15, 16, 17, 18, 19. 19 sigma bond. This is the correct answer. Which molecular ion out of the following does not contain unpaired electrons? So you have to draw the molecular orbital diagram of this nitrogen oxygen. So I will show you for this O2 2 minus ion. Okay. So this is the molecular diagram of the O2 2 minus. So first you have to find out the number of electron. O2 16, 2 into 18 plus 2, 18 electrons. Okay. So here important thing between this nitrogen and oxygen is this. Here sigma 2 pz comes first. For nitrogen it will come after the pi 2bx and pi 2by. So fill up this electron from the order of the increasing energy. Okay, so you will get here 2 plus 2, 4, 6, 8, 10, 12, 14, 16, 18. So there is no unpaired electron in the O2 2 minus. But if it is O2 only, then there are two unpaired electrons. When there is no unpaired electron, then it is called a diamagnetic. But when there is a unpaired electron, then it is called a paramagnetic. So O2 has two unpaired electrons, but O2 2 minus have no unpaired electrons. Okay, you can find the bond order also. There are 10 paired electrons. 2 plus 2, 4, 6, 8, 10. 10 paired electrons. There is unpaired electrons. 2, 4, then sigma star 2s, 6, sigma star 1s, 8. So 10 minus 8 by 2, that is bond order of 1. Okay. This is O to 2 minus have a bond order of 1. So this O to 2 minus doesn't have for the nitrogen, that is different in the book 31. See here, this is for the oxygen O2 molecule. This is the energy level, the order. But for nitrogen, carbon, boron, this is the energy level, order of the energy level. These two are different. Okay. Which of the following molecular ion bonds are not equal? So here this carbon C2H4 carbon to carbon double bond. The carbon to oxygen is a single bond. In which of the following substances will hydrogen bond be the strongest? Strongest. See, hydrogen forms are formed in common hydrogen combined with nitrogen, oxygen, fluorine. But here this is the only one option is there. Here HCl, Cl is atom is larger. There is atomic number is more, so there is no hydrogen bond is formed on that. If the electronic configuration of the element, okay, 4 electrons in the chemical bond, the outermost electrons only will involved in the chemical bond formation. So this is the correct answer, 3 to 4 s 2. Which of the following angle corresponds to sp3 sp2 hybridization? That is 120. 22. So here you see sp2, the hybridization. This angle, bond angle is 120. Okay. The electronic configuration of 3 elements A, B, C are given below. Answer the question 14 to 17 on the basis of this. See this A, this electronic configuration neon, B, phosphorus and chlorine. The stable form of A may be represented by the formula because this is octet complete and neon gas. So this is stable one only, A, neon. Stable form of C may be represented by the formula. This is chlorine. C exists in a Cl2 form. The molecular formula of the compound B and C. B and C. B is phosphorus. C is chlorine. That stable form is PCl3, stable compound. The bond between B and C is a covalent bond. B and C sharing of the electrons. Bonding between two non-metallic atoms. Okay. Which of the following order of energies of the molecular orbitals N2 is correct? So here this is a different from the oxygen. Okay, so I already showed you in the book between the nitrogen and oxygen energy levels. For the nitrogen, I will show you. So here for the nitrogen, you see pi 2px and pi 2pa comes first. After that only sigma 2pes is coming. See this 2p is having sigma bond, 2px 2ps having the 5 bond. So the question is, so this increase following energies of the molecular N2 is correct. You have to see this order and compare with this the diagram. Okay, the molecular orbital diagram. So this is increasing order of the energy level. This sigma star 2ps is at the top. After that, sigma star pi 2ps, sorry, pi star 2px, pi star 2py, then these things. So from down, sigma 1s, sigma star 1s, like that you have to go. Okay, so based on that, this is the correct order. Which of the following statement is not correct from the viewpoint of the molecular orbital theory? So here also for the nitrogen they have given the order of energy. See here, see sigma 2p is higher than the pi 2px. Okay, so sigma 2p should come before pi 2px. I already showed you the nitrogen energy level diagrams. Okay. Which of the following options represent the correct bond order? Here, how to compute the bond order? First, you have to draw the molecular orbital diagram for the oxygen. Then, from that you have to find the bond order. Okay, molecular orbital diagram for the oxygen. So this is the molecular orbital diagram of the oxygen. Okay, oxygen 2 minus I have drawn. Okay, you can see for, do it for the oxygen. Oxygen means so you should not add this last two electron. Oxygen means 2 into 16 electrons. So 16 electron means the 5 star 2px 5 star they will have only one electron each, because you have to use that above principle. First you have to fill up one electron each, then again after that you have to pair in the same orbital energy. So for that bond order, okay, bond order I computed based on that. So for the oxygen O2, O2 will have 16 electrons. Okay, O2 have 16 electrons. If you draw the molecular around 10 bonding, 6 anti-bonding. So bond order is 2. Here O2 minus the bond order is 1.5. O2 plus the bond order is 2.5. So O2 plus is having higher bond order. So here the O2 plus is the highest bond order. So O2 minus is the lowest. So that is this is the correct order. This is the formula is half into anti-bonding electrons minus anti-bonding electron. The electronic configuration outermost cell of the most electronegative element. Electronegative elements. Okay, these values. If you see the periodic table, from left to right it increases, and then the fluorine from the bottom to top it will increase on that fluorine column. Okay, among the following elements, whose electronic configuration is given below the highest ionization energy, highest ionization enthalpy. See, the half-filled and fully filled orbital are the more stable, so they will have the highest ionization enthalpy. Here, these two are half-filled, but this is closer to the nucleus. Okay. So, which of the two or more may be correct? Which of the following have an identical bond order? The isoelectronic atoms having the identical bond order. See, isoelectronic is nothing to do with the valence electron. You have to use the atomic number. Okay. Based on that, you'll see these two having the 14 electrons. So here they have the same bond order. Which of the following attain the linear structure? In book 22. See here this BCl2, they are having this is having the linear structure here. So from the book only they lost most of the questions. CO is isoelectronic with So again, this electronic configuration you have to put here. You have to remove one electron because of the positive sign. So these two are the correct answer. Which of the following species have the same shape? So CO to linear, tetrahedral V-shaped, V-shaped. From the book you can see. Which of the following statements are correct about the CO3 2 minus? See, CO3 2 minus ion they are given. They all, according to the experimental finding, all carbon oxygen bond in CO3 2 minus are equivalent. So here the average formal charge on the, see here you have to compute the formal charge on the oxygen atom, then divided by 3. 3 oxygen atoms are there. All CO bonds length are equal. Okay. So the option 3 and 4 is correct. Diamagnetic species are those that have no unpaired electron. Which among the following I already shown you for nitrogen and oxygen molecular orbital diagrams. So you have to draw it. Then you will see which are they having paired electron and unpaired electron. Accordingly, you will see the O2 minus no unpaired. Here also no unpaired. So this is on diamagnetic. Okay, species having the same bond order. Okay, here O2 F2 comes into the same orbital energies. Okay, oxygen, fluorine, and all. So they will have the same molecular orbital diagram structure. So they same bond order. The electron, same electron configuration, same bond order. Which of the following statements are not correct? Okay, there is NaCl being an ionic compound is a good conductor of electricity in the solid state. No, and the solid state. In canonical structure, there is a difference in no. The arrangement of atoms are same. I already shown for this CO3C here. The atoms are not changing. C is here, C is here, C is here. O is here, O is here. So the arrangement of atom is not changing in the canonical structures. Okay, short answer type. Question number 31. Explain the non-linear shape of H2S and the non-planar shape of PCl3 using the valence shell electron pair repulsion theory. Okay, so the presence of the lone pair actually causes the distortion in the structure. Okay, so here see H2S have two bond pairs and two lone pairs, PCl3 three bond pairs and one lone pair. So you can actually go through the book for this detailed explanation of this why it is attaining this shape. Using the molecular orbital theory, compare the bond energy and the magnetic character of this O2 plus and O2 minus ions. Okay, here you see more the bond order and the more bond energy. I already shown you how to draw the molecular orbital diagram and also how to compute the bond order. So here you'll see. So this is the molecular orbital that configuration for the O2 plus and O2 minus. That is also given in the book I already showed you. So then you have to compute the bond order. This is bonding electron minus anti-bonding electron. O2 plus bonding electron 2 plus 2 4 plus 2 6 8 10. Okay, 10 bonding electrons, anti-bonding electrons. Okay, 2 plus 2 4 4, then this one 5 5 10 minus by this is 2.5. Same way for the O2 minus ion, this is 1.5. So this is 2.5 and 1.5. Bond energy will be more for this O2 plus, is less for the O2 minus. Okay, so both have the unfed electrons, so they are paramagnetic. Okay, main thing is you have to remember this molecular orbital diagram of the nitrogen series and oxygen. See this oxygen fluorine one side, nitrogen carbon boron those other side. Explain the shape of the VRFI 25. See, this is the example. So this is the shape. So you can go through the book how this molecular shape and hybridization details. 34. The structure of the molecules of two compounds are given below. This structure and this structure. And they are asking which of the two compounds will have this intermolecular hydrogen bonding between the molecule, and which compound is expected to show the intramolecular hydrogen bonding within the molecule, bonding within the molecule and between the molecule. The melting point of the depends on among the other things the extent of the hydrogen bonding. On this basis, explain which of the above two components will show the higher melting point. Solubility of the water depends on the power to form the hydrogen bonds with the water. Which of the above component will form? See, these they are asking. From their answer only, I will show you the detailed answer. This is the compound. Okay. So here they have given the answer for A. The compound 1 will form the intramolecular hydrogen bond because N-Vot and OH groups are close together. Here N-Vot and OH they are close together. That is why within the molecule, intramolecular hydrogen bonding it is formed in comparison to the other compound 2. For the answer B, the compound 2 will have higher melting point because it forms the intermolecular hydrogen bond. Thus, more and more molecules are joined together the hydrogen bonding. And here, this forms the intermolecular hydrogen. Between the molecule, it forms the hydrogen bond. So, the melting point will be more for this compound. Similarly, due to the intramolecular hydrogen bonding, the compound 1 will not be able to form hydrogen bonds with the water, thus will be less soluble. Compound 2 will be so whichever forms the intermolecular hydrogen bonding that with the others, then it will be more soluble than the intramolecular hydrogen. This is less soluble and this is more soluble. Why does the type of overlap given the will not result in the bond formation? Here, you see this orbital is shared between this and this positive and negative equally. So, this will not overlap in the bond formation. Here, X and Y, they are in perpendicular axis. So, they won't form the bond formation. Explain why PCl5 is trigonal 5 pyramidal whereas IF5 is a square diagonal 25. So here this is the exemplar. So here you can go through the hybridization and the structure. In both water and dimethyl ether, CH3O CH3 oxygen atoms is central atom and has the same hybridization. Yet there is a different bond angles. Which one has the greater bond angle? Give the reasons. Okay, here. So they have given this hint. Dimethyl ether will have a larger bond angle. There will be more repulsion between the bond pair of CH3 group attached to each either between the bond pair of the hydrogen atoms attached to the oxygen in water. The carbon atom of CH3 is either attached to the three hydrogen atoms through sigma bonds and electron pair of these bonds add to the electronic charge density on the carbon atom. Hence, the repulsion between the two CH group will be more than the between the two hydrogen atoms. Write the Lewis structure of the following compound and show the formal charge on each of them. This is for the NO2 minus ion, but here they are asking for NO2, HNO3 and H2SO4. NO2. So this is the structure for the NO2. Here we see this is the structure for the oxygen 6 valence electron, nitrogen 5. Okay, the and there is here two oxygen atoms. This is the this Lewis structure. For the HNO3, we have hydrogen 1, nitrogen 5, and this 18. Okay, there are 24. And the 24 is distributed with like this. And here there is a double bond. This side, single bond, and single bond. And you can also compute the formal charge from the book. Okay, and the sulfuric acid H2SO4, first you have to draw for the SO4, then on the single bond side, when there is a oxygen with a single bond, there will be a negative charge. So on that charge a hydrogen will combine. So this side hydrogen, and here also oxygen with the single bond, there will be a negative charge. So the book it is given now the formal charge on the oxygen when there is single bond. I already shown you. So the side the hydrogen will combined with the O minus. Hydrogen combined with the O minus. The energy of the sigma 2 is molecular orbital is greater than the molecular orbital for the nitrogen molecule. I already shown you from the book and my diagram also. Write the complete sequence of energy level in the increasing order of the energy in the molecule. Compare the relative stability and the behavior of the following. So this is already given. I already shown you. You have to draw for molecular this orbital diagram for the N2. This is for the N2 plus N2 14 electrons, then plus we have to separate one, so that 13 electron. The important here is that here this pi 2px pi 2a comes before sigma 2pz. Okay, in that then you have to allot the electrons. So here you will see there is a one unpaired electron, then there is a this is a paramagnetic. Okay, but if you see this N2 is a diamagnetic because this is N2 N2 plus. So here remove, so N2 means 14 electrons only. So 14 electrons means this will be paired. This will be this will be paired. So there will not be any unpaired electrons. So N2 will be diamagnetic. So same you can do for N2 minus also. Okay, so this also like we are removing n to 14 electron means n2 plus will have only 13 electron. You have to draw this structure. Here oxygen 16 electron means it will have 15 electron. Then molecular orbital structure then you have to find the bond order. Give the reasons for the following. Covalent bonds are directional bond, ionic bonds are non-directional. Water molecule the bent structure, whereas carbon dioxide is CO2 no lone pair, but water has the lone pair. That is why it's a bent structure. Ethane molecule is linear. C2H2 25. So this is the structure and hybridization for C2H2. We are given this. This is the, so you can go through this for the details. And ionic bond is a non-directional because the charge is uniform in all direction. An ion is surrounded by the other ions from all direction. But covalent bond is directional because the side we are sharing electron, that side only the bond will be formed. What is ionic bond, and with two suitable examples, we explain the difference between the ionic and covalent bond. See here, this is ionic bond formation, NaCl. Na loses then one electron, Na plus, then Cl receives one electron, Cl minus. So this is ionic bond formation. Here the covalent bond formation, this is the covalent bond formation. Arrange the following bonds in the order of increasing ionic character. Give the reason. Electronegativity, you have to know the electronegativity of the each of the atoms from the electronegativity table, then find the difference. Then accordingly you arrange. So which one arrange the following increasing ionic character? Increasing ionic character. So that will be the least will come first. So the CH is the least. So that will become first. Then this is the order. Explain why CO3 2 minus ion cannot be represented by single Lewis structure. Uh, So here you see the expand the structure of, so the here they have, one structure is not enough because according to the experiment all bonds are equal. So there has to be three resonance structure like this. So remember these atoms will not change placement of the atoms, only this bond will be rotating. Here double bond and here double bond and here double bond. Then see the charge on the atoms. Wherever single bond is there, you have to put the negative charge. Single bond, negative charge, single bond, single bond, single bond. Predict the hybridization of the each carbon molecule and the organic compound. Give these indicate the total number of sigma and pi bond. The see carbon hybridization, you can read the book. Here you have to expand the CH and OH. See, they are asking the sigma bond. CH here they are not expanded. You have to expand. There is one more sigma bond here. See, triple bond have two bi bond. One single bond in all bonds. One bi bond has one bi bond in one double bond. Two bi bonds in a triple bond. Triple bond has two bi bond and a single sigma bond also is there. So here two bi bonds, one pi bond. Here one. 2 plus 1 plus 1. 4 pi bonds it is having. And similarly you have to compute the sigma bonds. Okay. Sigma bonds here one sigma bond CH is there. Then here also one, here also one, here also one, here one. This also you have to expand. This also you have to expand. Group the following as linear and non-linear molecule. Non-linear. BCL2 having the linear, but all the other things are the non-linear. BCL2 has a linear structure, other things are the non-linear structure. Okay, BCL2 only is having linear. Elements X, Y, Z to the valence electron given. Write the molecular formula of the compounds by these elements individually with the hydrogen. So here hydrogen forms single bond. And so when there is a 4 valence electron, now it is formed 5 7 valence electrons. Okay. So here the first four valence electron X4, XH4, that is CH for example. Here 5 valence electron PH5 sample. Then like that, the 7 means is only one electron is required. So is at H. Draw the resonating structure of ozone and nitrate ion. O3 is ozone. So O3 is ozone. This is the resonance structure, and this is the hybrid. And for the other thing, nitrate ion also O.2. O.3. This is Lewis structure. You can draw and find the formal charge. This is the nitrate and exactly they are asking, so you have to read it and understand. Predict the shape of the following molecule on the basis of the hybridization. BCl3, CH4, CO2, NH3. BCl3, CH4. So you can see everything is here in the book only. You can go through it. All CO bonds in carbon are not are equal in length. Explain. So this is again I already shown you in that book example. They have given an explanation. This is carbonate ion. You can go through it. So this is the you can go through it. What is meant by the term average bond enthalpy? Why is there a difference in bond enthalpy OH bonds in ethanol? Okay, when breaking the bond one by one, if you break one bond, then the remaining bond structure will change. So the bond enthalpy will be different when you break the next bond. Okay. Okay, matching type. Match the species in column 1, the type of hybrid orbital in column 2. So you can SF4C, that is sp3d, IF5 the A, sp3d3, there are 6 orbitals here involved in the hybridization, ENO2 plus E. So here 2 orbitals, NH4 plus D. There are 4 orbitals here involved in the hybridization. Match the species in column 1 with the geometry shape column 2. See, these are the answers. So you can read this and go through the book for this. Okay, match the column 1 with the column 2. Here you see This bond order, how you compute the bond order. The one thing you have to remember, isoelectronic configuration have the same bond order. Okay, so this is the bond order you can compute for NO 15 electron, and you can use the molecular orbital energy levels and find the bond order using the bonding electron and anti-bonding electron. Match the items. In the column, the example is given the hydrogen bond. Hydrogen bond, okay, is HF. Fluorine, NOF, nitrogen, oxygen, fluorine bonds, hydrogen bonds. So here F is there. Hydrogen bond. Um, Resonance. Okay, it's having this Lewis structure resonance for the ozone molecule, ozone thing. Ionic solid. This one. Covalent bond, carbon. Now the shape of the molecule column type and hybridization. Okay, this thing. Then accession type. Okay, sodium chloride formed by the action of the chlorine gas and the sodium metal is a stable compound. This is because sodium and chlorine ions acquire octet in the sodium chloride formation. Okay, sodium chloride formation and the octet combination. Yes, the A and R both are correct. R is the correct explanation of A. Though the central atom in NH3 and H2O molecules are sp3 hybridized, yet hydrogen bond angle is greater than that of the hydrogen. This is because of the nitrogen atom one lone pair and oxygen atom is two lone pair. Okay. Current more lone pair, more distortion. Okay. Among the two OH bonds in H2O molecule, the energy required to break the first OH bond, other side is same. No, this is not correct. Because second oxygen atom, if you break one bond, then the structure will change, the energy will be different. So both are false. Long answer. Discuss the significations and applications. So that is also in the book 13. Okay. So here they are given various dipole moments. Okay, you can go through it and go through the explanation also. Use the molecular orbital energy level diagram. Show that N2 would be expected to have the triple bond and F2 single bond. So because you have to find the bond order using the molecular orbital energy level, then after that you can show the bond order. No, this is bond. Briefly describe the valence bond theory and bond formation by taking the example of hydrogen. How can we interpret energy changes taking place in the formation of dihydrogen? So this hydrogen molecule, how it is formed, and the other details you can go through it here. Okay, the changes taking place in the formation of the dihydrogen. So you can go through this and answer the question. Describe the hybridization in the cases of PCl5SF3 year 26. So they have given how this is formed, this SF6 and PCl5. So you can go through it and answer that question. Discuss the concept of hybridization. What is the different types for the 24 for the carbon hybridization? So here is for carbon hybrid C2H6 and other hybridization C2H4. These things are mentioned here, so you can go through it for the different type of vibration in the carbon atom. So here we given the some example. Molecular orbitals are formed by the overlap of atomic orbitals, and the two atomic orbitals combine to form the two molecular. There is a molecular atomic orbital and a molecular orbital. The same number it will be formed. So they given the energies of the various molecular for element hydrogen to nitrogen in the increasing order. So this is for the nitrogen, and this is for the oxygen and fluorine. So that is in the book also they are mentioned in the book. In the book also it is there. They both are different. Um, Okay, now different atomic orbital of one atom, so the atomic orbital of the second atom will have the comparable energy and proper orientation. Further, if the overlapping is head on, the molecular orbital called sigma and the 5 bonds formation. The molecular orbitals are filled with electron according to the or the filling of the atomic orbital, that is half of principle. However, the order of the filling is not same for the all molecules in the hydrogen, and this nitrogen and oxygen are different. Bond order is one of the most important parameter to compare the strength of the bond. Which of the statement is correct? The formula dioxygen from oxygen atoms, 10 molecular orbitals will be formed. Okay, in the oxygen. For the oxygen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that is correct. That is the correct answer. Okay, which of the following molecular orbitals have the maximum number of nodal planes? Nodal planes where there is no electron. Okay, so here there is no electron in the nodal plane. Which of the following is expected to have the same bond order? So here O2 16, okay, 16 minus 1, 16 minus 1, 15, N2 minus is 16, N2 14 plus 1, 15. So you can draw the molecular orbital, although those structure energy levels are different, but they will have the bond order, same bond order. In which of the following molecules orbital is filled after this is important, okay. So this is in the nitrogen one, in the nitrogen, so I already shown you. Okay, so all the concept will be clear. You go through the books and repeatedly you have to read. Okay.